Okay, so we are doing a lesson today on parabolas, which you've done parabolas before because we did a whole chapter on quadratics, but we now just add in some extra information about parabolas. So, quick review, circles. This here is the equation in standard form. Remember that in order to be a circle, the ax squared has to be there, the cy squared has to be there, so we need an x squared term and a y squared term. And a should equal c exactly. So 2 equals 2, negative 2 equals negative 2, 5 equals 5, right? Those two values have to be equal. For a parabola, there's two different standard forms, and that because depending on which variable is missing will change which way the parabola opens. So one option is you could have this first equation here. Notice what's different is that there's no y squared term. So there's only an x squared term. Or in the second scenario, there's only a y squared term. There is no x squared term. So the key thing for a parabola, to identify a parabola, is that it only has an x squared or it only has a y squared. The other squared term is missing. It doesn't matter at all about these guys, right? So one of these could be missing, doesn't matter. It's all about the squared terms, okay? Clean that up a little bit. So if we look back to our name that conic, right, here's a different set of conics. Pause the video and see if you can identify the circles and the parabolas. If you caught on to what we talked about last time, you can even challenge yourself to find the ellipse and the hyperbola. Go for it. So our circle is number 1. And the reason this is a circle is because it has the x squared and it has the y squared, and those a and c values are equal to each other perfectly. Our parabola is number 3. Reason being it doesn't have a y squared term. And then that's it. Okay, now the other ones are either ellipses or hyperbolas. So let's just go through them quickly. Number 2 is a hyperbola. Something is a hyperbola if it has both terms, x squared and y squared, but they're opposite signs, positive and negative, or negative and positive, doesn't matter. But one's positive, one's negative. That's the hyperbola. Number 4, it has both terms, but those a and c values are not equal. That's your ellipse. Think like it's almost a circle, but because the 3 and the 8 aren't the same, it doesn't have this perfectly round shape. It's more ovalish, right? So ellipse. And then in number 5, we've got both terms, but one's positive and one's negative, right? Doesn't matter. Notice the difference between number 2 and number 5. Doesn't matter about the numbers themselves, just positive and negative, opposite signs. So this was hyperbola. Cool. All right. Next. When you think of a parabola, what's the first equation that comes to mind? So parabola, hopefully you're thinking quadratic, which hopefully you're thinking parent function is y equals x squared, right? Hopefully that's what you were thinking. Now what we're going to do is I'm just going to walk you through some things here. All I did was change it, right? X squared equals y, and you know that this, hopefully, you know that this is a parabola that opens up with a vertex at 0, 0. So when you see this, and the reason why it's switched is because oh, did I say the wrong thing before? I did. This was general form. Sorry about that, guys. General form. When we look at our standard form, we're always going to put the squared term on the left-hand side. Remember, only one term is squared, either x or y. And we're always going to put that squared term on the left. So it'll say x squared equals y, and this is your most basic one that you already know, and that opens up. How do we make a parabola open down? Hopefully you're saying we add a negative sign. So for our standard form for a parabola, oh man, giving you guys clues that I don't want you to see yet. For our parabola, for our standard form, we're going to add that negative sign to the right-hand side. See it in front of that y. So that's where the negative sign will appear. We're used to adding a negative sign here to make it open down. So we're just going to relocate that, and we're going to put it on the other side. Okay, I'm going to get rid of this so you're hopefully not tempted to do that. So that opens down. Now, for the first time, I think, you're going to now see parabolas that open left and right, which we have not done before. So to make a parabola open left or right, what we're going to do is square the opposite term. So if the x is squared, that's your most basic that you know, up and down. But if the y is squared, it's going to go left and right. So it will open right if the y is squared, but it's a positive in front of the x. And it will open left if the y is squared, but there's a negative in front of that x. Some people just like to memorize this kind of stuff. I always just kind of go through this thought process of, I know what this means, so based on this first thing, I can figure out the other three. And this way you're never memorizing something. I've said this multiple times, if you memorize, that's when you just forget. But if you understand, you can always like figure it out. So take that for what it's worth. All right, so now here are some examples of things in standard form. We're adding more stuff to it. So we've got these two standard form equations down at the bottom of the screen. So what we've added is we've added the h comma k, which is going to be your vertex. We've also added this 4a that's out in front. This 4a is what's either going to stretch or compress the parabola. So the bigger that 4a value is, that whatever that number is, the wider the parabola would be. It's going to be really wide parabola. But if the 4a is a smaller number, then that parabola is going to be super narrow, right? First thing we want to focus on here is let's just go through which way things open, up, down, left, and right. So remember, your most basic one is y equals x squared, and that opens up, okay? If you feel comfortable, you can pause the video and go through and see what opens up and what opens down, left and right. So I'm looking at example 1, I see y equals x squared, right? It's just a little bit out of order, but I see y equals x squared. I also see a positive in front of the y, right in this location here. So I'm going to say this opens up. For example 2, I also see y equals x squared, which is our most basic parabola we know. But this time I see a negative in front, so I'm going to say this opens down. For number 3, I see the y is being squared this time, which is not what we're used to. So I'm thinking left and right. That negative tells me left. And same thing for number 4. I see the y value is being squared, which is what we're not used to. And I'm seeing a positive here, so I think that is right. Okay? So whatever works to get you those up, downs, left, and rights, make sure you understand that. Now for the vertex, it's just your h comma k. Notice here the h is on the left and the k is on the right? And that's going to be your vertex. Over here, notice the h is on the right side of the equation, but the k is on the left. It's still going to be h comma k though. So let me show you an example of where it gets tricky. Let's go through these. So example 1, h comma k, remember we're doing opposite of everything, so it's going to be negative 4 comma 2. Everything's the opposite because of the way the formula is written. We've talked about this in other chapters. For example 2, this would be 0 comma negative 3. In example 3, this is where people usually get it wrong. It's 1 comma 3. Because this is the x, this is the y value. Just look at the letters, x and then y, right? So just be careful. A lot of people say 3 comma 1. And then vertex is negative 3 comma 5, right? Again, the x comes first, then the y. Make sure you pay attention to that detail. Okay, next, the definition of a parabola. It's the set of all points that are the same distance from the directrix and the focus. So for a circle, it was a set of all points that are the same distance from the center. For a parabola, it's a set of all points that are the same distance from the directrix and the focus. Okay, weird words that you may not have heard before. So we've got this parabola here. And there are two things now that you didn't know existed before. There's a point, usually somewhere around here, called the focus. The focus is inside the parabola, always inside. So even if my parabola opened like this way, there's my focus. If my parabola opened down, there's my focus. If my parabola opened left, there's my focus. So it's always inside the parabola. Now, it's always a certain distance away from the vertex. Here's our vertex. Okay, so it's always a certain distance away, which we'll talk about in a second. So it's not just a random point, right? There's a way that we know exactly where that point goes. The other thing that's mentioned is the directrix. The directrix is a certain amount of spaces away the other way from the parabola, okay? And it's going to be the same distance on both sides. And then it's not a point, it's a line. And this line is always basically perpendicular to that axis of symmetry that's going to go right down the middle of the parabola. So here's our axis of symmetry. All right, this is our axis of symmetry. The directrix is perpendicular to that. I'm going to get rid of that axis of symmetry, though, for a second. Come on. Right, so this is what we call the directrix. So the directrix is a line. Directrix. So the set of all points, every point on the parabola is going to be the same distance to the focus and to the directrix. So here's the point on the line, on the parabola, the vertex. It's going to be A spaces to get to the focus, and then A spaces to get to the directrix. So this vertex is smack dab in the middle of the focus and the directrix. Now, based on the definition of a parabola, if I pick any point, right? So right here, that red point, the distance to the focus, and it's not drawn to scale, so I apologize, and the distance to the directrix are equal. So I really not drawn to scale. This distance and this distance are equal. Okay, again, let me try to draw the parabola better of what it would actually look like, so it looks more realistic. Let's try like that. Okay, so now let's try again. Let's see if our picture looks a little bit better. So I put this point here, this distance to the focus, and then this distance to the directrix are equal. So this line would be congruent to this line. Okay, so I hope that helps. And this would be true for any point on the parabola. So if I put a point here, this distance to the focus, and then this distance down to the directrix would be equal. Again, my drawing is not perfect. So that's the definition. I think there's some importance to understanding it so that when we're going through this, you're like, what's the point? Why am I graphing this thing? And you're graphing the focus and you're graphing the directrix because they're part of the definition of what a parabola actually is. Okay, so this is the A value. And that A value comes from that formula, that 4A. Okay, why is it 4A? Quick explanation, but we're not going to spend time on this. It's 4A because when you branch out through that focus from side to side, this is 2A and this is 2A, which gives you a total of 4A. So this whole thing is what we call the lattice rectum. Yes, it's a very funny word. Lattice rectum, and it's 4A. We're not going to spend time on that this year because we're modifying the curriculum. So good for you if you caught on to that. All right, what am I up to now? Let me just check my notes here. So the directrix, when we list it, it's always going to be an equation. So in this case, it's like y equals, and then it would be whatever the y value is. Focus is an ordered pair. Then we've got this axis of symmetry that goes right down the middle of the parabola. That's the axis of symmetry. Again, in this case, it would be x equals a number, right? Now, if my parabola opens a different way, so let's just say the parabola opens to the right, my focus would be this ordered pair. Here's my vertex. Here's my directrix. My directrix this time would be x equals. My axis of symmetry would be y equals. All right, I know I said that fast, but we'll go back. Okay, so some reminders here. We've got these two standard forms in red, right? Up and down versus left and right. The LR, which again, we're not going to really focus on that this year. The LR and the A value, which we are going to use, the A value, they're always positive because they represent a distance. So when I ask you what's the A value, you should be saying a positive number because it's a distance. The focus is always inside the parabola. The directrix is always away from the parabola, and it never touches the parabola. You might also want to add here like the directrix is perpendicular to the axis of symmetry, right? So that might be helpful. All right. So let me go back to this screen here. Let's talk about the A value really quickly. So this number, let's just start with example 4. This number that's out in front, that's that A value, that 4A value. So this is equal to 4A. So 4A is equal to 2. So A is equal to 1/2. And what that tells us is that this parabola is very narrow. Here, we would say 4A equals -12, so A equals -3. The negative sign is just telling us which way the parabola opens. The 3 is telling us like a vertical stretch. So this is going to be a wider parabola. I think I said that wrong. Forget the word vertical stretch. This is going to be a wider parabola because of that A value. Go back here. 4A equals -8. So the A value here would be -2. Again, we would be counting 2 spaces, so A is positive, right? And then here, there's an invisible 1 in front. So 4A equals 1, so A equals 1/4. So this is going to be a very narrow parabola. All right. Okay. Here we go. We are going to rewrite this parabola from general form into standard form. We did this with the circle. The procedure is very similar. First thing we're going to do, we need to complete the square. First thing we're going to do is get rid of that 4 that's out in front because we can't complete the square with that 4 there. So we're going to divide the whole entire equation, both sides, by 4, no matter what, even if we don't like there's fractions involved. So it does divide evenly for this question, which is nice. But let's say, for example, this was a 13 instead. You got to deal with the fraction. Yucky, yucky, yucky. But you don't have a choice. You have to divide by 4. So -3 equals 0. The next thing we're going to do is we're going to figure out which term is squared. So the x is squared here. We're going to keep that on the left-hand side, and we're going to move the other variables and the constant to the right. So we're only going to keep the squared term on the left. I'm going to leave a space to complete the square, and I'm going to move, this should be negative. I'm going to move my y and my constant to the other side. The next thing I'm going to do is complete the square. So what do I add into that space to complete the square? Hopefully you're saying 1 squared. Whatever you add to one side, you have to add to the other to balance it out. I'm then going to factor this. I'm going to combine like terms on that right-hand side. And then one more thing I have to do. You need that 4A out in front. So no matter what, you have to factor out this number. So I'm going to factor out a -2. And that leaves me with this. So this right here has to be a 1y. It is possible that you might end up with a fraction here where that -2 is in the parentheses. It just might happen because of the way the problem works. So now this is my standard form. So let's go through our checklist here of fill in the blanks. What's the vertex? The vertex would be -1, 2, h, k. The LR, again, we're going to skip this for this year, but so you can skip the blanks. Those of you that want to know the answer is 2. It's that 4A value, but again, don't worry about that. The A value, we're going to take this number, set it equal to 4A from the formula, and solve for A. So A equals 1/2. I'm going to say it's positive because A is a distance, so I'm going to ignore the negative sign. Which way does this open? I see y equals x squared, but I also see that it's -2. So that means it's going to open down. Where is the focus? Okay, so this might be where you want to start to just draw a sketch. We're not going to graph like on full graph paper. So -1, 2 is my vertex. The focus is going to be here inside the parabola. And how far away did it go? right? What's this distance? It's a spaces. So we're going to count a half a space down. So what we've done is we've moved the y value. We're subtracting to go down on the y value. So the -1 is still the same, but I'm taking the 2 and just going down a half. So this is going to be 1.5. So my focus is -1, comma, 1.5. The directrix is going to be a half a space the other direction. Ugh, I wish I had. Can I move everything? No. All right, sorry guys, it's gonna look a little sloppy for a second. So we're gonna move a half a space the other direction. And so we're moving up. So we're starting at the 2 and we're going a half a space up. So now we're at 2.5. And the directrix is this line that's perpendicular to the axis of symmetry. So it's going to be a horizontal line here, which I know is y equals, and that number is 2.5 because I went half a space up from the 2. And then the axis of symmetry is what splits the parabola right down the middle. So it's a vertical line, x equals, and I'm using my x value from my vertex, which is also the x value from my focus. Okay? So that's that. I'm going to go through one more really quickly. If you want to skip ahead, you can if you don't think you need another example. But I think some people might need it. All right, so here's another example. First thing we're going to do is divide everything by 3 because we can't have that 3 there. So this would be y squared hold on a second. I'm looking at, on my paper, I'm looking at the wrong thing. All right, let's just go through it. Look, I'm looking at the wrong thing in front of me right now. So plus 4y minus 2x plus 6 equals 0. So then we're going to keep the squared term on the left-hand side. We're going to move everything else to the other side. I'm going to complete the square. Whatever you add to one side, you have to add to the other. Factor. And then I have to factor out this 2 that's in front of the x. It has to be a 1x inside the parentheses. So here is my standard form. Going through the questions, what's the vertex? Be careful here. 1, comma, -2. The LR would be 2. It's just this number that's out in front, but again, you don't have to worry about that. The A value, take that number that's out in front, set it equal to 4a from the formula. Am I doing the same exact example again? No. Really? Get a half again? Should have switched it up a little bit. Which way does it open? So I see x equals y squared. So this is a left or right problem, and it's going to open right because of the 2 here that's highlighted being positive. So we're going to open right. Right? If you're good, you can do the rest of this without a picture, but most of us need a picture to start. So I'm going to draw a parabola that opens right. Label the vertex as 1, comma, -2. The focus is inside the parabola. So I'm going to move half a space because it's A, right? A space is away. Half a space to the right. So this time, the x is what's changing. So I'm going to move half a space to the right to 1.5. But the y value did not change. I didn't move up or down. So this is going to be 1.5, comma, -2. The directrix is going to be a spaces the other way. So this is A, which is a half. So I moved A spaces the other way, and it's a vertical line at x equals, and I took this I took the x value from the vertex and I moved half a space left of that. So I'm going to subtract a half from the 1 to get me 1/2. The axis of symmetry goes right down the middle of the parabola. So it's y equals, because it's a horizontal line, and that y value, I just look at my y values of my vertex and focus, -2. There you go. All right, last thing we're going to do is write the equation of a parabola. So from the other lesson, to write the equation of a circle, you need the center and the radius. Those are the two things you need. For a parabola, you need 3 things. For the parabola, you need the vertex. You also need which way the parabola opens, up, down, left, or right. And then you also need either the LR or the A value. And again, this year we're going to focus on that A value. So these are the 3 things you need in order to write the equation of a parabola. We're going to do 2 examples. So write the equation of a parabola that has this vertex and this focus. So my suggestion, I always say, and we usually spend much more time on this in school, vertex opens A value. So I say vertex opens A value. And this is like my little thought bubble. And once I get these 3 things, I know I can go write my final answer. So I have the vertex. And that's about all I have for right now. Now I'm going to draw a picture and figure out these other things. So just a sketch, -2, 4 would be somewhere around here. That's my vertex. And then -2, 2 is my focus. So knowing that this is the vertex and this is the focus, I can draw a little sketch of what the parabola would look like. The focus is always inside the parabola. So from that, I know it opens down. And my A value is the distance from vertex to focus. So this is A. So how far apart are the vertex and the focus? You can either just count spaces or you can do the distance formula if you really needed to, but these are 2 spaces apart, so my A value is 2. Okay. Once you have all that information, we're going to go write the answer. First thing, figure out which variable is being squared. If the parabola opens down, that means that it's y equals x squared. So I'm going to put the x on the left-hand side. That's the squared term. And then the y is on the right-hand side and it's not squared. Then I'm going to fill in my vertex. So the x value goes in the x parenthesis, but opposite. The y value, the 4, goes in the y parenthesis, but opposite. I then need to put this number in front. That's my 4a value. So my a value is 2, so 4 times 2. This is going to be an 8. And then last, I check to see, do I need a negative sign, yes or no? And because it opens down, yes, I need a negative sign. So I'm going to add a negative to that 8. Final answer. All right, last one. Write the equation of the parabola with a focus of 3, 2 and a directrix of y equals 4. I'm going to get my thought bubble going here. Vertex opens A value. I don't know anything just from the information given, so I'm going to start to draw a picture. Focus is 3, 2. Right, I'm just going to label that F for focus. Directrix is y equals 4, so I'm going to go up to 4. And that's my directrix. Where would my parabola be? Based on the definition, directrix focus, the vertex would be right in the middle of those 2 things. And then it would look like this. So we've got another one that opens down again. I should have switched it up. Sorry about that. Okay, so if this focus is at 3, 2, and this directrix is up at y equals 4, where would the vertex be? Well, the vertex is on the same line as the focus, so 3, and then it's halfway in between the focus and the directrix. So if this is at a y value of 2 and here's a y value of 4, our vertex must be at a y value of 3, halfway in between. So our vertex is 3, 3. And then the a value is the distance between vertex and focus, or between vertex and directrix. Either way, you get the same answer, which in this case is 1. So let's write the equation. Because it opens down, I know that x is being squared. Again, sorry about the lack of variety here. The y value is not being squared. And then in front of the parentheses, I'm going to put my 4a value, a being 1. So this is going to be a 4. And because it opens down, I'm going to use a negative sign. Final answer. And so that is parabolas. Sorry it's a little long. That's what I'm going to give you guys some extra time to do this. And to make it all better, I'm going to give you an awesome joke right now. What did the math student say when his pet bunny tried to steal his parabola? So I'm going to pause and let you pause the video if you want to and think about it. What did the math student say when his pet bunny tried to steal his parabola? Silly rabbit, Directrix are for kids. Get it? Because like tricks are for kids and a bunny and yeah. I think this is a kind of clever one. I like this one. All right, have a good night, guys. Bye.